Hi, welcome to Automotive Appreciation Part 2. In this section we will cover camshafts and valves. There are various layouts for the camshafts. Early engines had the camshaft at the bottom of the engine. The valves were operated by push rods via rocker arms, hence the name push rod engine. An advantage of this design was that it was easy to lubricate the camshaft with oil. However, at high speeds, the rods were prone to loose contact with the cams due to their inertia. SOHC, Single Overhead Cam. In this design, the camshaft was relocated to the top of the engine and driven by a timing chain or belt. One camshaft was used to operate both the inlet and exhaust valves via rocker arms. In a DOHC or dual overhead cam, separate cams were used for inlet and exhaust valves. With a non-interference engine, the valves do not extend into the path of the piston. If the timing belt breaks, it will not result in damaged valves. With an interference engine, the valves extend into the path of the piston. If the timing belt breaks, it will result in damage to the valves. Valves are used to allow air enter and exhaust gas exit from the cylinder. They are opened by the lobe on the camshaft and closed by spring pressure. Usually inlet ports are larger than exhaust ports, as it is more difficult to get air into the cylinder. Early engines had only one inlet and one exhaust valve per cylinder. Modern engines usually have two inlet and two exhaust valves. The top position of the piston is called top dead center, TDC, and the bottom position is called bottom dead center, BDC, while the volume between the two is called the swept volume. The total engine capacity is the swept volume multiplied by the number of cylinders. For this engine, the compression ratio is 10:1. A diesel engine would be higher at perhaps 20:1. Initially, one might think that on the intake stroke, the inlet valve should open at top dead center and close at bottom dead center. Similar with the exhaust stroke, the exhaust valve should open at BDC and close at TDC. If we look at the inlet valve closing at BDC, we see that a flow of air is blocked behind the valve from entering the cylinder. It would be much better to delay closing the valve until the increasing cylinder pressure stops the flow. Then we get more air into the cylinder. Similarly with the exhaust stroke near bottom dead center, the combustion stroke has most of its work done. Best to open the exhaust valve early, thus expelling more of the waste gas. We use a timing diagram to show the valves opening and closing. Near top dead center of the exhaust stroke, both inlet and exhaust valves are open for a short period. The flow of air from inlet to outlet is called valve overlap and aids scavenging of the exhaust gas. A camshaft can operate the valve directly, or usually a cam follower or tappet is used between the cam and the valve. Sometimes the camshaft lobe is offset from the center of the valve and tappet to encourage the tappet and valve to rotate as it is pushed down. To allow for expansion as the engine heats up, it is necessary to have a small gap between the tappet and cam to ensure the valve is fully closed. Note, the area around the exhaust valve is the hottest part of the engine. A further development is the hydraulic tappet. This tappet is extended by high pressure oil through a non-return valve. The tappet will occupy the available space between the cam and the valve, thus eliminating any noise as the cam strikes the tappet. It will also ensure the valve can close fully at all times. As there is always a small oil leakage from the tappet, this will allow it to retract as the tappet heats and expands. By manufacturing different type cams, engine manufacturers were able to design engines for high efficiency or high power. Cams for racing cars were called race cams or high lift cams. By altering the lobe profile, they would open the valve earlier, further and for longer, usually at the expense of fuel consumption. With VTEC, the camshaft has two separate lobe profiles. The valve is in contact with the blue rocker arm. At low speed, the cam operates on the standard profile for efficiency, and at high speed, the pin is activated by oil and the rockers are joined together when they are aligned, thus altering the timing and lift for maximum power. Cam. A further development was VVTi. This uses a system where the position of the cam relative to the pulley can be adjusted, thus altering the valve timing for power and efficiency. Depending on driving conditions, high pressure oil is fed through the camshaft into a chamber, thus rotating the pulley on the camshaft. When the oil is released, the cam advance is removed. It is normal to adjust timing on the inlet valves. With a double overhead cam engine, it is possible to adjust both inlet and exhaust valves independently of each other. Note, VVT only adjusts timing, but VTEC adjusts both timing and lift. We hope you learned from automotive appreciation.